The process begins with an automatic magazine that feeds steel bars into the production line. The system operates with a power output of 1450 kW and a heating frequency of 500 Hz, ensuring uniform heating and optimal material properties for subsequent processing. This high-performance press can handle heated steel bars with diameters of up to 130 mm, ensuring the billets are precisely cut to the required dimensions for shell casing production. The billets are then transported to the Umuco hydraulic press, which performs the crucial forging stage. This press is capable of handling steel shell casings weighing up to 50 kilograms and consists of two specialized units. Compression and push broaching unit. With a force capacity of 630 tons and a drop hammer traverse of 1,250 millimeters, this unit compresses and shapes the billets into preliminary shell casing forms. Drawing unit. This unit employs rolls and rings to calibrate the forged shell casings. Using a force of 200 tons and a drop hammer traverse of 3,200 millimeters, it ensures precise dimensional accuracy, improving the shell casing's structural integrity. Once forged, the hot shell casings are arrayed into pallets using a robotized stacker. This automation ensures consistent alignment and positioning, allowing the casings to cool uniformly before undergoing normalization, heat treatment, to refine their microstructure and mechanical properties. GF Programmable Hydrocopying Lathe. This high-efficiency lathe performs the initial turning of the shell casings, focusing on shaping the outer surface with precision. Its programmable features allow for quick adaptation to different shell designs, ensuring both speed and accuracy. Final 130:1 Programmable Lathe. For final machining, this lathe focuses on the inner surface of the shell casings, achieving tight tolerances and a polished finish. This step is critical for ensuring the casing's compatibility with internal components and its functionality under high-stress conditions. Automated magazine for billet charging. This magazine ensures a continuous and precise supply of billets for bending, streamlining the process and reducing downtime. EMA Inductive Heating Unit. 375 kilowatts power and 1000 Hz frequency. This reheating ensures the material remains ductile for bending while maintaining its mechanical integrity. Usain de Wecker Vibrating Forging Press. The bending itself is performed by this press, which applies controlled force and vibrations to bend the shell casings into their final shapes. This method ensures precision while minimizing stress concentrations that could weaken the casing. 1. Barrels. The heart of precision, the barrel is the foundation of a firearm's accuracy, and at Holland, its production is a process. Precision begins with selecting the finest steel, often in the form of forged blanks. These blanks are drilled and reamed to create the bore, a process that requires absolute accuracy. Even the smallest deviation can impact the trajectory of a shot. Once the bore is formed, it undergoes a process called lapping. Craftsmen use abrasive tools to polish the inner surface of the barrel, ensuring it is smooth and consistent. This refinement contributes to the gun's unparalleled accuracy and performance. The barrels are then tested rigorously for strength and durability, often exceeding regulatory standards. After the technical shaping, the barrels are joined using methods like brazing or soldering, depending on the gun's design. Double-barrel shotguns, for instance, require precise alignment to ensure that both barrels fire in unison, converging at a specific point downrange. This intricate process is both a science and an art, requiring a skilled hand to achieve perfection. The creation of fine sporting shotguns and rifles is an art form as much as it is a technical endeavor. Holland, one of the most esteemed names in the world of gunmaking, has been synonymous with unparalleled craftsmanship since its inception in 1835. Each gun that emerges from their workshop is a masterpiece, reflecting a balance of artistry, functionality, and precision engineering. Stock. A fusion of form and comfort. The stock is the part of the gun that connects the shooter to the firearm, and its crafting demands both ergonomic and aesthetic considerations. At Holland, the finest walnut wood is selected for its strength, resilience, and beauty. Walnut's natural grain patterns lend each gun a unique character, making no two stocks identical. Once the wood is chosen, it is carefully shaped to ensure an ergonomic fit. This step involves an intimate understanding of the shooter's preferences, body dimensions, and intended use for the gun. Skilled craftsmen carve the wood to create a seamless connection between the shooter and the firearm, ensuring comfort and balance. The stock is not merely functional, it is also a canvas for artistry. It may be adorned with intricate checkering, which provides both grip and aesthetic appeal. The painstaking hand checkering process involves carving tiny diamonds into the wood, a skill that takes years to master. The result is a stock that is as beautiful as it is practical. Action. The mechanical core. The action is the mechanical heart of the firearm, responsible for loading, firing, and ejecting cartridges. At Holland, crafting the action is a testament to precision engineering. Each component is hand-fitted, ensuring smooth operation and reliability. The process begins with the machining of steel blanks to create the various components of the action, such as the locks, triggers, and hammers. These parts are then hand-filed and polished to achieve a perfect fit. The precision required at this stage is extraordinary. Even the smallest imperfection can affect the gun's performance. Holland guns often feature side-lock actions, a hallmark of fine gunmaking. These actions are not only mechanically superior, but also provide a platform for intricate engraving, further enhancing the gun's aesthetic appeal. The assembly of the action is a delicate process, requiring a deep understanding of both mechanics and craftsmanship. The manufacturing process of a Holland firearm is a journey through tradition, innovation, and artistry. From the precision of the barrels to the elegance of the engraving, each stage is a testament to the dedication and skill of the craftsmen involved. The result is not just a functional tool, but a work of art, embodying the perfect combination of form and function. Engraving. Artistry in metal engraving is where craftsmanship meets artistry. At Holland, master engravers transform each gun into a unique work of art. Using hand tools and a steady hand, they etch intricate designs into the metal surfaces of the action, barrels, and other components. The designs often include traditional motifs such as scrollwork, floral patterns, and game scenes, but they can also be customized to reflect the owner's personal tastes. This level of personalization makes each gun a true one-of-a-kind masterpiece. Engraving is a time-intensive process, with some designs taking hundreds of hours to complete. The engraver's skill lies not only in their ability to create intricate patterns, but also in their understanding of the gun's overall design. The engraving must enhance the gun's aesthetics without compromising its functionality or balance. Finishing. The final touch, the finishing process, brings all the elements of the gun together, creating a harmonious whole. It involves a combination of polishing, coating, and assembly, each step carried out with meticulous attention to detail. The metal parts of the gun are polished to a mirror-like finish, enhancing their beauty and protecting them from corrosion. The barrels may be blued, a chemical process that gives them a deep, lustrous black finish. Meanwhile, the wooden stock is treated with oils and waxes to enhance its natural beauty and protect it from the elements. Once all the components are finished, the gun is carefully assembled. This stage requires a high level of precision, as even the slightest misalignment can affect the gun's performance. The assembled gun is then tested rigorously to ensure it meets Holland exacting standards. Finally, the gun is presented to the customer, ready to be admired, cherished, and used. Each firearm represents the culmination of hundreds of hours of labor by some of the world's most skilled craftsmen. The process begins with the drawing pre-operation, where brass or similar material is prepared for further processing. In this stage, metal sheets or rods are cut into blanks of appropriate sizes. The forming press is used to shape the cartridge case further. Next, the cartridge cases undergo head turning and finish trimming. The head turning process involves machining the base of the casing to achieve the exact dimensions needed for proper chamber fit. After trimming, the casing mouth is annealed to soften the metal. Annealing involves heating the neck and mouth area of the casing to a specific temperature, making it more malleable. This is essential to allow proper crimping of the bullet during later stages and to ensure the casing can expand and seal the chamber during firing, preventing gas leakage. The full metal jacket FMJ transfer press is used to produce the bullets. This process involves forming a lead core and encasing it in a copper or brass jacket. The FMJ design enhances the bullet's performance by providing a smooth exterior surface, reducing deformation during firing, and improving penetration. The primer insertion machine plays a critical role in ensuring reliable ignition. In this step, primers are precisely inserted into the base of the cartridge casing. The primers contain an explosive compound that ignites when struck by the firing pin, initiating the firing sequence. Accurate placement of the primer ensures consistent performance and reduces the risk of misfires. The loading machine assembles the ammunition by inserting the FMJ bullet into the prepared cartridge casing. The casing, primer, and propellant are carefully combined before the bullet is seated. During this process, the amount of propellant is precisely measured to ensure consistent muzzle velocity and ballistic performance. To protect the ammunition from environmental factors such as moisture, a sealing machine applies a thin layer of sealant around the primer and bullet. This step improves the reliability of the ammunition, particularly in adverse conditions, by preventing water or oil from contaminating the primer or propellant. The final step in the manufacturing process is packaging. The packing machine organizes the finished cartridges into boxes or other containers, ensuring they are securely stored and ready for transport. TİSAŞ, a prominent player in the defense industry, with over 30 years of expertise, is renowned for its innovative manufacturing practices that blend advanced technology with craftsmanship. The company's production processes are characterized by in-house operations, rigorous quality control, and an unwavering commitment to excellence. TİSAŞ manages its entire production cycle internally, starting with sourcing raw materials and progressing through to the finished product. This vertical integration allows for greater control over quality and cost efficiency. The company employs sophisticated production lines, where different machining techniques are applied to optimize various components and assemblies. At the heart of TİSAŞ's manufacturing process is its research and development (R&D) unit, which continually pushes the boundaries of innovation. Guided by professional user feedback and market trends, the R&D team designs new firearm models using specialized CAD software. These designs undergo rigorous testing for criteria such as system compatibility, ergonomics, and shooting performance. Advanced modeling techniques and 3D printing ensure that prototypes are not only functional, but also feasible for production, streamlining the transition from concept to reality. A significant portion of the manufacturing process is executed with computer numerical control, CNC machines, equipped with high-precision pneumatic clamping systems. These machines, combined with custom CAM software, allow for multi-axis machining that enhances production speed and flexibility. By minimizing human intervention and employing fixture-based model transitions, TİSAŞ reduces equipment downtime and maximizes efficiency. The company's adoption of Six Sigma methodologies ensures that processes are measured, analyzed, and optimized systematically. The barrel, a critical firearm component, is manufactured entirely in-house using the cold forging method. This globally recognized technique enables TİSAŞ to produce barrels of any caliber and length, while ensuring superior shooting durability. The result is a product that meets the highest standards of precision and reliability. Specialized heat treatment and coating processes further enhance the durability and performance of TİSAŞ products. These processes are governed by automated workflows, ensuring consistency and efficiency. The heat treatment facilities optimize the hardness of metal parts, while coatings are applied in precision-engineered baths. Material structures are analyzed at the micro level in a dedicated laboratory to guarantee consistency in quality. Quality control is a cornerstone of TİSAŞ's manufacturing philosophy. Every component and final product undergoes thorough testing for performance and compliance. The company's in-house laboratories are equipped with advanced testing devices that are regularly calibrated and audited by accredited organizations. Shooting performance is verified in NATO standard ranges, ensuring accuracy and reliability in real-world scenarios. 1. Lead wire and bullet production. The process begins with the production of lead wire, which forms the core of the bullet. High-purity lead is melted and extruded into long, cylindrical wires of a specific diameter. These wires are then cut into uniform segments, which are shaped into bullet cores through a mechanical pressing process. For full metal jacket FMJ bullets, commonly used in 9x19 mm cartridges, the lead core is enclosed in a copper jacket. This jacket is produced by drawing copper sheets into small cups, which are then swagged around the lead core under high pressure. The result is a smooth, aerodynamic bullet with consistent weight and dimensions. Depending on the intended application, the bullets may also be designed with hollow points or other specialized features. 2. Case production. Cartridge cases, typically made from brass, are manufactured using a series of mechanical operations. Brass sheets or rods are fed into automatic presses where they undergo a process called drawing. In this process, the brass is progressively shaped into hollow cylindrical cases through multiple stages of deformation. Once formed, the cases are annealed to relieve stress and improve their malleability. This involves heating the cases to a specific temperature and then cooling them in a controlled manner. After annealing, the cases are trimmed to their precise length to ensure uniformity. The final step in the 9x19 mm ammunition production line is cartridge assembly, where the bullet, case, primer, and propellant are combined into a finished round. Primer insertion. A primer, a small metal cup filled with a sensitive explosive compound, is inserted into the primer pocket at the base of the case. The primer's placement and alignment are critical to ensure reliable ignition. Propellant loading. A precise amount of gunpowder or propellant is loaded into the case. Automated systems measure the propellant to exact specifications, as even minor deviations can affect performance or safety. Bullet seating and crimping. The prepared bullet is seated into the case mouth and the case is crimped to secure the bullet in place. The crimping process ensures that the bullet remains stable during handling and firing while maintaining proper headspace. Conclusion: the production of 9x19mm ammunition requires high levels of precision and automation to meet the demands of reliability, safety, and performance. By following structured steps, lead wire and bullet production, case manufacturing, and cartridge assembly, the production line ensures consistent quality for military, law enforcement, and civilian users worldwide.